Hi students, now I am going to discuss about pointer arithmetic. Pointer arithmetic is the set of valid arithmetic operations that can be performed on pointers. So now if you see the different operations in the pointers, the first one is increment of a pointer, decrement of a pointer, addition of integer to a pointer, subtraction of integer to a pointer, and comparison of a pointer. Now we will see one by one. If you see the increment of a pointer, this is nothing but it is an increment, a pointer by pointer with start pointing to the immediate exit location, or I can say immediate next location. Go with a one example. Here the variable has been assigned to 10 value and the data type is an integer. Now declare the pointer. The pointer is also an integer. Now in the pointer, it holds the address of this variable. Okay. Then the pointer gets incremented. This can also be read as pointer is equal pointer plus 1. So thereby you can say the pointer incremented by 1 and now start pointing to the immediate next location. Then how to calculate the new address from the current address? New address is equal to the current address plus I into, that is asterisk, size of data type. Now we will see how to calculate the new address. So now here if you take the variable that is n of type integer, now n has been taken as 10 as a value. The compiler will provide an address to this variable. Similarly, pointer is also a special variable where it is also providing with an address. But here this pointer is holding the address which is related to this variable address. So I can say that pointer is holding the address of the variable called n. And now to calculate the new address, here take the current address which is this is the current address. Take the current address and here this is 1 asterisk size of integer. Here according to this architecture, 32-bit architecture, the integer size is nothing but it is 2 bytes. It is 2 bytes. So now after calculation 1 into 2, if you add that with this address, you will get this address after update. Go to the next operation, that is called decrement of a pointer. Means decrement a pointer by 1. So the pointer will start pointing to the immediate previous location. Okay. So now here n is allotted to 10 value, which is an integer. Declare the pointer which is an integer, and now pointer is holding the address of this variable. Then its decrement, the pointer decremented. This can be read as pointer is equal pointer minus 1. So this pointer is decremented by 1 and now start pointing to the immediate previous location. Now then, how to calculate the new address from the current address? So now if you observe here, n variable n is equal to 10, and the compiler providing the address for this variable, and this address is hold with this special variable called pointer, and the compiler is also provided an address to this variable also. Now to calculate the new address, take the current address, that is -1 asterisk size of an integer. So I said you that it is a 32-bit architecture. So the integer size is nothing but it is 2 bytes. And here, so if 2 into 1 and you subtract from this, and you will get this address after update. Next come to here, the addition of integer to pointer. So it is very simple. Here we have added an integer to the given pointer. Okay, see, at the time of adding a pointer with an integer value, while you are calculating the new address, first the value is first multiplied by the size of the data type and then add to the pointer. So means first you go with the multiplication, then you go with the addition. Okay, so now take the same example. Int n is equal to 10, declare the pointer, and in this pointer pointer is holding the address of this variable, and now the pointer is simply added with an integer 3. So now to calculate the new address, taking the current address plus I into size of data. So here n is a variable, n is equal to 10 according to the given example, and the compiler allotted this address to this variable, and this address is held by the special variable called pointer, and also the compiler providing some address to this special variable. So now here this is the current address, which is 65524, plus here this is an integer that we are going to add. So 3 asterisk size of integer. So already I said you that according to 32-bit architecture, here the size is 2 bytes. So 3 into 2 is 6 bytes. So if you add to this current address, it will get that this is the current address after update. This is the new address after update. Next, if you go with the subtraction of an integer to a pointer, so here when a pointer is subtracted with an integer value, the value is first multiplied by the size of the data type and then only subtract from the pointer, which is very similar to the addition. So first do multiplication, then only go for subtraction. So now take the same example. Int n is equal to 10, declare the pointer, and pointer is holding the address of the variable. So after that, the pointer is here we have subtracted with 3. Now calculating the new address is equal to the current address minus I into size of data type. So now here in this example, n is a variable which is an integer having the 10 as a value. Compiler provides address to this variable which holds by this special pointer, and this pointer is also having an address. And here to calculate the new address, so taking this current address minus 3 into size of integer. I said you that the size of the integer is 2 bytes. So now 3 into 2 is equal to 6 bytes. So you subtract the 6 bytes from the current address and finally you will get a new address after update. Next, come to the last but not least is the comparison of your pointers. So when you are comparing the two pointers using the comparison operators, so now it returns true for the valid condition. It returns false for the invalid condition. Okay, so here it returns true for the valid condition. So here, so based on this valid condition, and it returns false when it is a invalid condition. Now we will see one program based on this pointer arithmetic. So write the C program using arithmetic pointers. So now hash include stdio.h header file of C program and int main, write the C main function, start the execution from here. Now here n1 assigned to 10 value which is an integer, n2 assigned 12 value which is an integer, and now declare the pointers, two pointers, one is pointer 1, the second one is pointer 2. These two are also integers. Now here pointer 1, in pointer 1 we can see the address of the first variable. In pointer 2 we can see the address of the second variable. Now prompt the user to print pointer 1. Okay, so now this next operations assumes a specific memory layout which is not guaranteed and would likely lead to undefined behavior, or I can say it is unexpected results. Okay, so now we will see all the conceptual operations. The first one is increment. So increment, so this is nothing but pointer plus 1 and the asterisk. And the decrement here that we can see here pointer minus 1 with the asterisk. Next, come to the addition. So here this is a pointer with the dereferencing plus 3. Similarly, go to the subtraction. Here pointer 1 with the asterisk minus 3. Next, come to here. Pointer 1 is undefined. Pointer 2 is also undefined. So now here, which are undefined variable, that is pointer 1 and pointer 2. Printf comparison. So here it simply go with the comparison is pointer 1 is equal to pointer 2. And after that result 0, close the brackets and start execution successfully. Now the output automatically he will get it as the first, know that the pointer 1. So the pointer 1 here is nothing but if it is 10, n is allotted to 10. The second one is a decrement, which is a pointer 1 minus 1. The decrement here, so we can see that this is when allotted by the compiler. And come to the decrement. So decrement is nothing but, so here the pointer 1 minus 1, so having a dereferencing operator, and now the decrement will becomes 12. Now addition value will get it, and also subtraction value also will get it as an output, and pointer 1 and also the pointer 2. And here come to the comparisons. Here the comparison, here we can see that address of n1, that is the address of pointer 1 and pointer 2, if these two are equal, If these two are equal, we can say here the comparison is 1. If these two are not equal, we can say that the comparison is 0. Got it? Thank you.